Hi, my name is Duojia Li, and my student number is 217157546. And based on my student number, question 4 is assigned to me for this final exam video submission. So for question 4, the question is asked to find the bending stress and the safety factor, right? And I just list all the givens in the question. We're given that the pinion has the tooth of 18, and the gear based on the my serial number is 42, and we're given that the pressure angle is 20, the horsepower is 10, and the speed is 480. The geometric factor is, after calculation, is 0.411, and the phase is 2.5. The quality is 7. So let's find this step by step. So first one we're gonna focus on is the bending stress. For the bending stress, we can just apply this equation, and we need to find each of these variables one by one, like the transmitted load, the factors, the size factors, load factors, dynamic factors, and so on, all of these one by one. And then at the end, we just plug everything into this equation, and then to find the stress. So first one we're gonna focus on is the transmitted load. So we find dP first, which is 3 inch, and after finding dP, we can find the pinch velocity by subbing the dP, and the speed is 480. And by using this equation, we find that the velocity is 376.99 feet per minute. And then we use this equation to convert it to the transmitted load. And after this, we got it's 875.3547. And then for the KO, because the load is uniform, so load factor is just 1. And then for the KV, we can just use the equation from the textbook, which is 14/27. And then in this equation, we have A and B, 2 factors, and this V is just from here. So basically, we just need to find A and B, but we know the A is, we use the equation. We know the equation of A is this, and the equation of B is here. We need to working backward because A need to B to solve. So we find B first. B is 0.52 at the end. We just need to calculate numbers given the question, which is 7. So B is 0.52, and we sub B back to the A, and we find A equals to 76.8788. And then we have A, we have B, we have V, so we can find KV. KV, just plug in all the numbers we have. So KV equals to 1.12423. And then we can find KS. So for KS, we first need to find Y in order to calculate KS, because here's the equation for KS. We need the phase we know is 2.5 is given. PD is 6 that we calculated before. So now the only variable is Y, so we need to find Y first. So from table 14.2, we can find Y. But the problem here is on the table, there's no Y value that corresponding to 42. We need to use the linear interpolation to find the 42. So I picked 2 points, is the 43 and 38, because of the 42 is in between of these numbers. So we did some calculations. The Y is only variables here. Here should be Y. Y is the only variable in this equation, so we can find Y equals to 0.394, and then we plug this Y value and phase value and PD to the KS equation, and then we get the KS equals to 1.10946. And then we can find KM. KM is a little bit complicated because we need to find those C values, those little factors for KM. And then we can, after we find these factors, we sub it back to the KM equation to find KM. And we're given that the gear is unchroned, so the CMC is 1. And for the CPF, we know from the textbook, because the F, the value, the face value is between 1 and 17 inch, so we got to use this equation. And then there's also a line that for this equation is if the first value, the F over 10 dP, is smaller than 0.05, we're going to ignore it and use 0.05 instead. And then by calculations, I found that this value is 0.041. is obviously smaller than 0.05, so we're gonna ignore it and use 0.05. And then this is constant, and then this is constant, and this is 2.5. So basically you can just sub it in and calculate. And I found the CPF is 0.04375. And then we made some assumptions, and also from textbook, the CPM is 1, C is 1. And then we're gonna move on to CMA, and we know the equation is A plus B times phase plus C phase squared. And from the table of 14.9, and then because we know it's commercial, so we can just find the A, B, C that's in the table. And then again, F is 2.5, that is a number that we know, so basically we can just find CMA. And finally is 0.165919. So after we find everything, we just sub it back into the Km equation and find that Km equals to 1.209669. And then also from textbook, from the 14/40, we got the Kb equals to 1. And then now we have all the K values, and then we have the load, the transmitted load, and we have the geometric factor, we have everything. So we can just sub everything back into the equation. And then we find the stress equals to 12851.85203 psi. And I think this is the answer for part A. And then we can move on to the safety factor question, which is the part B. We know the safety factor equation is ST times YN over KT KR over the stress, which is 12851. So now we just need to calculate these 4 terms, and then we plug it back into the equation so we can find the safety factor. So for ST, we're given that it's grade 1, so we can use this equation from the textbook 14.2. And then we're given that the hardness of this is 250, so we sub it in and find ST equals to 32125. And then for the number of cycles, the question gives that the gear need to last, the pinion need to last that 66667 hours, and I convert into minutes. It equals to this much minutes. And then by the relation of 2 gears, that the RPM for the small gear times the teeth equals to the RPM for large gear times the teeth. So basically, I use the speed times the teeth equal to find RPM for the big gear. So I find that RPM for the big gear is 205.714, and then this is the RPM. This is radius per minutes, right? And then we have the total minutes that it needs to last. So I just multiply this number to this number, which is here, and to find the total radius it needs to last, which is 822.861.257.1, and then I convert into cycles, which is 130.999.512 cycles. And then we can use the equation 1414 from the figure 1414 to find yn, because we have the cycle. It's the only variable here. And then we can find that yn equals to 0.97209. And then for the reliability factor is that in the question it gives that for every 1,000 product there will be 1 fails, right? So the 999 products will pass. That's why the pass product over the total product, it will gives you the reliability, so which is 0.999. And from the 1410 from textbook, the table, it gives you that at the reliability of 0.999, the KR, the reliability factor is 1.25. And for the temperature factor, we assume it's 1. And then we have all of these 4 things, 4 variables, and also we know the stress. Therefore, we can just sub in all the numbers into this equation and find that the safety factor is 1.94389. And that's it for this question. Thank you for listening and watching. Have a nice day.